Guess who's back? Ready to do some factoring with cubics and factoring with quartics with the hand? Here we go. Factoring cubics. We're going to look at two different types of cubics. We're going to look at the sum of cubics and the difference of cubics. And we're also going to look at factoring of quartics. Let's begin with what a cubic is. Remember, a cubic is anything to the third power. So if we have x to the third, and let's say we add to it another term that is to the third power as well, or a cubic. Here we have the sum of perfect cubes. What we can do is factor this, and the way we're going to factor this is by taking the cube root of each of these terms. So we're going to take the cubed root of x to the third, which is going to be x, and the cubed root of y to the third, which is y. And we're going to bring down that same sign. Our second quantity is going to be based off of this first quantity. We're going to begin by squaring this first term, or multiplying it by itself. So if we take x times x, we get x squared. We're going to multiply the two terms together and change their sign. So if I have a positive x times a positive y, I get positive xy, but I'm going to change its sign so I get a minus xy. And finally, I'm going to multiply the last term to itself. So I get y times y, or y squared. Our last term will always be positive. Since we multiply a number to itself, we always get a positive number. This also works if we have subtraction of perfect cubes, or the difference. So if I have x to the third minus y to the third, say. Same process is going to happen. I'm going to take the cubed root of x to the third, or x, the cubed root of y to the third, which is y. My sign stays the same. I'm going to multiply the first term to itself, so I get x squared. I'm going to multiply the two together and change the sign, so plus xy, and multiply the last one to itself. Notice I get negative y times negative y, which is a positive y squared. In both of these cases, this trinomial will not factor anymore, because we cannot multiply to get a positive y squared and to get a negative 1. Here, a positive y squared to get a positive 1. So let's go ahead and put some numbers into this and some example 1. So let's take x to the third plus 8. Notice we have two cubes, x to the third, and 8, which is equal to 2 to the third. So to factor this, we're going to take the cube root of x to the third, which is x, the cube root of 2 to the third, which is 2. Our trinomial, we're going to take x and multiply it to itself, so x squared. We're going to multiply the two together and change the sign. And we're going to multiply the last one to itself. 2 times 2 gives us 4. And that's our factored form. Example 2, we can get a little more complicated by making the first term 8x to the third minus, let's take 27. So to factor this, we're going to take the cubed root of 8x to the third, which is 2x, because 2x times 2x times 2x gives us 8x to the third. The cube root of 27, well, 27 is 3 to the third, so the cube root of 27 is 3. There's our binomial. Our trinomial, based off of the binomial, we're going to multiply 2x to itself. 2x times 2x is 4x squared. We're going to multiply the two together and change the sign, so plus 6x. And finally, multiply the last one to itself. Negative 3 times negative 3 gives us positive 9. Again, this last trinomial will not factor for us. And let's do one more example. Let's do 125 x to the third plus 64. Here 125 is 5 to the third, 64 is 4 to the third. So our factorization is 5x plus 4. And our trinomial, we're going to multiply 5x to itself. So we get 25x squared. Multiply the two together and change the sign, so minus 20x. And finally, 4 times 4 gives us plus 16. And that's the factoring of cubes, sum and difference. Now let's go ahead and go into the factoring of quartics. To look at the factoring of quartics, well, we first have to remember what a quartic is. A quartic is a polynomial with degree 4. So anything to the 4th power. So if we look at an example, we'll call this example 4. Let's do x to the 4th minus 81. Notice x to the 4th is a perfect 4th power since it has the 4th exponent. 81 is 3 to the 4th. Well, x to the 4th minus 81 is going to factor very similar to our quadratics. So we're going to multiply the first two terms to get x to the 4th. And that would be x squared and x squared. To multiply to give us negative 81, and that's going to go into our last two sets. But notice we don't have a middle term. So we're going to have a minus 9 and a plus 9. If we were to look at the multiplication of this, notice our middle term is going to cancel. We have a negative 9x squared and a positive 9x squared. However, or lo and behold, looking at x squared minus 9, that factors as well. We have x minus 3 and x plus 3. And then our x squared plus 9, we know that that factors in the complex numbers as x plus 3i and x minus 3i. But what we want to do is leave it since we're going to work in the real number system at this point. If we look at example 5, let's take x to the 4th minus 5x squared plus 4. Notice our exponents, we have x to the 4th and we have x squared. And if you remember, this looks very similar to if we had x squared minus 5x plus 4, which was a quadratic. Notice we had a 2 to 1 ratio here, since our exponent here is 1, and here we have a 2 to 1 ratio. So it's going to work very similar to our quadratics. And we're going to notice that quartics and quadratics are very related as we go on through our polynomial unit. So we're going to factor our x to the 4th to get our first two terms. Here we get x squared and x squared. We're going to factor a positive 4 to get to a negative 5. And that's negative 4 and negative 1. Notice if I multiply these two together, I get negative 4x squared. If I multiply these outsides together, I get negative 1x squared. And adding those together gives me that negative 5x squared. And from here we can go ahead and factor. X squared minus 4 is x minus 2, x plus 2. And x squared minus 1 is x minus 1, x plus 1. And there's our completely factored form. In example 6, we're going to see 4x to the 4th minus 28x squared plus 48. Notice this gets a little more complicated. But what we can do is factor out a GCF. Notice 4 goes into each of these terms to begin. So I get x to the 4th minus 28 divided by 4 is 7x squared, and 48 divided by 4 is 12. Now I can look at this trinomial that's inside. Notice I have that 2 to 1 ratio, just like my quadratics, and it's going to factor just like a quadratic. So I get x squared and x squared. Multiply to give me 12 and add to give me negative 7 in this case. I get minus 3 and minus 4. Well, x squared minus 3 isn't going to factor anymore, so we're going to leave it as x squared minus 3. X squared minus 4 factors to x minus 2 and x plus 2. And there's our completed factored form. So to recap, we looked at the factoring of cubes, the sum and difference. We took the cube root of each of the terms, We multiplied the first one to itself, multiplied together and changed the sign, and multiplied the last one to itself. And we also did quartics, which are going to factor very similar to our quadratics. And that is factoring cubics and quartics.